Now to find the optimal leverage, remember that we said what? That the objective function for the manager was the expected utility as a function of profit and risk. Well, now we have a function. Instead of just purely conceptual, we actually have a functional form. We say that we're going to maximize profit, and we define profit as the expected rate of return to equity. It's also a function of risk. And the risk, we said, was going to be defined as the variance associated with the rate of return on equity. We see that as profit goes up, our expected utility goes up, but because there's a negative, as the risk goes up, our utility goes down. So what combination of that is going to maximize our expected utility? Notice that this RC, a new terminology, represents our measure of risk aversion. So a person that's more risk averse puts more weight on the risk. Somebody that was risk neutral, where this RC was 0, means that the full weight would be on the expected profit. But the greater that individual's risk aversion goes up, the more weight they put on risk. Now, we're not going to go through all the arithmetic of this, but basically what we're going to do is substitute equation 1 that you have in your notes, and we're going to substitute that in for the rate of return on equity. And we're going to take equation 2 and we're going to substitute that in for the variance of the rate of return on equity. And both equation 1 and 2 are part of your notes. Then we're going to take the first order conditions of that function with respect to leverage. We're going to set it equal to 0, and then we're going to solve for L, which gives us the optimal leverage. I'm going to give you a quick summary of why you've learned calculus. And it's interesting, calculus, all you're trying to do is find the slope of a line. If you have a graph, and over here we have the expected utility, and over here we have leverage, then what we find is, with our leverage going from no debt, as we add a little debt, what happens to our profit? We said that leverage is going to have a positive impact on our profit, right? As long as the return on assets is greater than the cost of debt. And if that's not the case, we're not even talking about this anyway. Okay? So we see that as we add debt, increasing our leverage, our utility goes up. But what happens to risk? It increases, but it increases faster. So what would you expect to happen to this line? It increases, but it increases less, so the slope is going down up until a point it actually peaks out, and at some point you got so much debt, it's a negative. Okay? Now we said we were going to take the slope of this expected utility line and we were going to set it equal to 0. That means we're setting the slope equal to 0. Where is the slope equal to 0 on that line? There at that top. The first order conditions is taking the slope of that line. That's your calculus. That's what the calculus does for you. And when we set it equal to 0, we're saying, where's the slope equal to 0? And where that slope is equal to 0, that gives us what? Maximum possible utility. If we followed this formula, we would solve for the L, and it would give us this particular formula. This formula that you see at the bottom of the screen gives you a mathematical equation to solve for your optimal leverage. So if we use these same pieces of information that we used before, and we assumed a risk aversion coefficient of 4.63 and another one for comparison of 3.086, and plugged it into that equation on the previous slide, we'd see that the optimal leverage for the first individual is 33%. For the second individual, who is less risk averse, willing to take on more risk, actually increases their leverage to 1, which means they have as much debt as they have equity. And what does that mean to their expected returns? okay, using our equations that we've identified before, you see that the less risk-averse individual, that person willing to take on more risk, actually has a higher expected return. And you'd also expect that the person that takes on more risk also has a higher risk, has higher profit but higher risk. And also notice that the person that is less risk averse also has relatively more risk associated for each dollar return. So the coefficient of variation goes up. The optimal leverage then, as you could see from the previous slide, depends on the level of risk averseness of the individual. So every one of you here, given the same firm, would probably choose a little different debt level. Rule of thumb in agriculture, okay, and obviously this is rule of thumb and very specific to certain parts of the country and certain farming, but just to give you an idea, in agriculture, usually lenders think that anything less than 33% is favorable. Anywhere between 33 and 1, okay, a maximum of where you have as much debt as you have equity is still satisfactory. But anytime you start getting more debt than you have equity, lenders start to get a little suspicious because your collateral value is being diluted. Obviously, different industries have different ratios depending on how much risk is associated with it. You know, some farms that are very dependent on government programs where there's not much risk, you know, they can probably take on more debt. Where if they're subject to the full effect of the market, probably have less. But here's the real measure of how much leverage you should have. Okay, it's called the sleep quotient. And it's something, you know, you need to think about. And basically, if you're leveraged out so much, it's hard for you to sleep at night because you know that if you get certain things happen, it's going to wipe you completely out and you're going to be penniless and you're going to be working for Sanderson Farms in the freezer cutting meat. You wake up at night, you know, worried about that. If that's the case, maybe you better back off. Here's our formula. We can use this formula conceptually. If we look at this optimal leverage, what can we say about the impact of this profit margin, this return on assets relative to the cost of debt? What impact does that have on your leverage? The greater that margin is, the greater the leverage. You know, it makes perfect sense. If my interest rate is only 10% and I can expect to get a 30% return, fairly certain, I'm going to borrow a lot of money, right? But if that margin is only 10% cost of debt and I only pencil out a 10.1% yield, am I going to leverage very much? The greater the profitability, the greater the expected profit is on that investment, the more leverage you're willing to take on. What's the impact of the risk aversion coefficient on leverage? The more risk averse a person is, what happens to their willingness to borrow money? It goes down, right? Which makes sense. Now I want to conclude with this concept of risk balancing that I think is very interesting, and it ties back to the political arena. If you look at this, we define business risk as the variance surrounding the return on assets weighted by taxes. So if we look at this in this formula, if business risk goes down, what happens to leverage? Goes up. It makes sense too, right? The less risk you have, so you're pretty certain that the return on assets is always greater than the cost of debt. As that risk reduces, the more leverage you're willing to take on. What's the impact of leverage on financial risk? This was our formula for financial risk. As leverage goes up, what happens to financial risk? It goes up. Now watch this. As business risk goes down, leverage goes up. As leverage goes up, financial risk goes up. Okay, keep that in mind. Some government programs are designed to reduce business risk. These programs that have support prices, prices go below a certain level, the government kicks in and pays you, or you can sell your crop to the government in a loan, and if the prices get too low, the government just takes it, non-recourse type loan. You know, in agriculture, there's a number of programs that the government uses to reduce business risk. So business risk goes down in agriculture, then what do farmers do? As the risk goes down, it gives them encouragement to go out and what? They can borrow more money. Look at that formula. The optimal leverage goes up. They go out and borrow more money. As they borrow more money, what happens to financial risk? So what happens to the overall total farm risk? Well, we don't know that, but it could. The unintended consequences. If you don't learn anything else from college, you need to know that unintended consequences. Politicians buy votes, and they have these good intentions, but you got to see the whole picture, because in this particular case, it's called risk balancing. Again, government reduces the business risk, farmers borrow more money, financial risk goes up. Now, I can't say that total risk increases, but certainly the effect that the government programs been put in place to reduce risk is offset because of the additional debt that is borrowed. Hopefully you think about that, because out there in a lot of things that we do, there's unintended consequences that we don't actually pay attention to. So also there's more sample problems using this formula for the rate of return to equity. It's in your handout.